Hi, my name is Doug Helms. I'm the VP of Business Development at Diametric. For those of you not familiar with Diametric, we're a developer of intelligent signaling systems. Today, we're going to put intelligence back into the signaling network. For years, we've heard vendors talk about the massive growth of diameter signaling traffic. We've heard that diameter signaling traffic will grow more than twice as fast as mobile data traffic. We've heard that chatty user applications such as email and Facebook will increase the amount of signaling. If an app requests access to the network while the device is dormant, then it might take 30 signaling events for the radio to switch from idle to a state where data can be exchanged. We've heard about spaghetti networks and how we can fix those with diameter signaling controllers. We've heard about signaling storms and the need to gain control over the network. But we don't hear about signaling intelligence. SS7 had IN, the intelligent network. Well, today we're going to give diameter signaling some IQ. There's a lot of information flowing over your signaling networks. The question is, how can I make use of it to deliver a better experience for my subscribers? How do I retain them, delight them? How do we connect the dots? Well, first, let's talk about what data exists in the diameter signaling control plane. The information that flows in the control plane contains the most valuable and strategic information in the network: the location of the subscribers, their phone number, the kind of handset they use to connect to the network, their available bandwidth, their charging methodology, their IP address, services they are using, their remaining balance, etc. Let's look at the information flowing between the MME and the HSS. We can see what type of radio the subscriber is coming over. Is it Wi-Fi, HSDPA, LTE? We know where the subscriber is located. We know what kind of handset they're using. Is it an iPhone? Is it running iOS version 7? How much data is requested? Looking at the information flowing between the PCRF and the P gateway, we can capture the maximum upload and download bit rates, the guaranteed bit rates, the charging methodology, how we're measuring their usage, duration, or data volume. Looking at the information flowing between the P gateway and the OCS, we can view the subscriber's usage of services, what was requested, what was used, what is the remaining balance. We have full visibility of what's going on in a specific device. The signaling control plane sees what services are being used and how active those services are. The network operator has real-time access to the signaling and the rich information it contains. Simply put, we have a complete set of information to make the smartest decisions at any specific moment. Now, to be clear, the diameter signaling plane is not the only source of rich information about the subscriber. The SIP signaling plane has valuable data as well. So does the data stream when accessed via deep packet inspection. When you put all these together, you get a complete picture. So we have all this data. So what can we do with it? There are multiple possibilities. First, let's look at data analysis. A marketing department might want to get information on a recent launch of a new smartphone, the services and bandwidth used, and how that compares to usage of other smartphones. Or the marketing department may wish to better understand the usage habits of visitors on its networks based on the type of smartphone they are using. There's applications such as legal intercept. As Vodafone recently disclosed, governments do request to legally monitor the usage of certain individuals. The signaling control plane offers real-time access to this data. Another application is the ability to detect network fraud in real time, or troubleshooting, being able to put an immediate trace in a customer's phone when they have called in to report a problem. Even better, a proactive approach to customer service. Take a situation where a subscriber is roaming, and the home subscriber server gets a message asking to connect to roaming, but is disallowed. That message could be examined by an application that recognizes the subscriber is a premium subscriber and proactively sends an alert to the operator, allowing your customer service department to become aware of the problem prior to the customer calling. Additionally, thanks to organizations such as the GSMA and its One API initiative, this information can be monetized through sale to non-mobile operator organizations. For example, the location of the mobile handset can be correlated with an overseas credit card charge attempt to prevent credit card fraud. All these applications can be enabled through the control plane. Mobile network operators can utilize this information to improve their businesses. And thanks to organizations like the GSMA and the One API initiative, this data can be easily monetized through the One API exchange. So great, we have tons of rich data. We know that we can make good use of it. Now, how do we get to it? How can we capture it to send it to reporting engines? Or how can we interrupt the regular signaling flow to add some additional logic? Some might think that putting in monitoring solutions or probes is the answer. However, there is a better way. All of the diameter signaling messages pass through the diameter signaling controllers at the heart of the network. The secret is to deploy a diameter signaling controller with intelligence, one with IQ. What do I mean by IQ? Well, a diameter router with IQ should be able to allow the operator to easily add logic onto the router. The operator should be able to change the routing logic on the fly for all subscribers or a subset of subscribers. The diameter router should be able to provide three methods of operation. First, standard routing, the ability to make a routing decision based upon any parameter or group of parameters. Second, notify mode. This is a variant of standard routing. The message is still routed based on the parameters. However, a copy of the message is made, and an application is provided a copy of that message. Third, interrupt mode. This is where the normal flow of routing is interrupted. Rather than making a standard routing decision, the router recognizes a special signaling case, and the message is actually sent to the application layer for special processing and then returned to the router. A few special notes. First, the application does not need to be on another system. Rather, it can be on the same system, and a memory-to-memory transfer can occur. Second, the application need not to be a single application. Rather, it can be a group of applications. The DSC has the intelligence to load balance within the application group. Let's take a look at some examples. Here is a simple case. In this example, the marketing department wants to compare data usage between different types of smartphones. So they set some filters. First, a filter is set to watch the S6A interface between the MME and the HSS. On this interface, the filter is set to look for location update messages. These messages contain the terminal manufacturer, model, and software version of the handsets. This information is sent to a reporting application that stores the data for future use. Note the routing of the message is not affected. A filter is set to watch the GUI interface between the P gateway and the charging platform. On this interface, a filter is set to look at credit control messages. These messages contain the data usage volumes for a particular subscriber. This information is also sent to the reporting application. The reporting application would then correlate the usage data with the handset data and produce the reports that marketing needs. Let's look at a more advanced case. This example is a roamer steering application. In this case, we will look for update location request messages. This is the message that is sent when a subscriber attempts to authenticate on a visited network. In the example I am going to show you, the diameter router will first identify the request as one it is interested in. Then it will interrupt the normal signaling flow. Rather than send that message to the HSS for authentication, it is going to send it to a special roamer steering application that will decide if the message should be sent to the HSS. So here we go. First, a filter is set to watch the S6A interface between the MME and the HSS. On this interface, the filter is set to look for update location request. Note that the filter might be set only to look at the update location requests for requests coming from specific countries, or it could be set for certain types of phones, etc. Rather than route that information to the HSS, the intelligent diameter router will recognize it needs to send this message to the roaming steering application group. The roamer steering application has a logic to analyze such things as, is this the best network for this user to attach to? Is this my least cost network? Is this a premium subscriber, and should I try to direct that subscriber to another network? For this network, the roamer steering application decides that another network is a better choice and rejects the message. So now the handset attaches to another network and tries that one. Again, the update location request is attempted, and the intelligent diameter routing intercepts that message and sends it to the roamer steering application. The roamer steering application says, yes, this is the preferred network for the subscriber, and sends the message back to the intelligent router to be relayed to the HSS. The HSS now authenticates that user and sends back an acceptance to that subscriber. So in this case, we can enable the operator to make decisions as to the best service selection for every roaming smartphone device, giving all the businesses and operational alternatives available. By deploying a diameter router agent with intelligent roaming capabilities, in addition to the GSMA required diameter edge agent functionality, operators can benefit from real-time control of the user experience when roaming abroad. So how do we develop and deploy these applications? First, we have to develop the application using the Diametric Application Development Platform. Diametric provides an application development platform that includes 3 sample applications: a roamer steering application, a sample reporting application, and a mapping application that tracks handsets based on the subscriber's user equipment. Once the application is developed, it is registered with the Diameter router. The next step is to create a filter. How you do this is you create a message filter on the DRA or DEA to identify messages that will be routed to the application. Filters can be set on any Diameter AVP or even multiple AVPs. Both and or logic is supported. By the way, this is the actual user interface on the Diameter routing engine. Finally, we connect the application to the message filter. Simply select the registered application and indicate if this application is a notify message or an interrupt message. A notify message is where a copy of the data is sent to the application. An interrupt message is where the normal flow of routing is interrupted for special signaling message processing. Great! So now we know that the signaling control plane has a wealth of rich data. We also know there are methods available so that you can access the data in real time. But who's going to help you get to it? Diametric has formed the Diametric Next-Gen Application Group, the DNA Group. We can assist mobile operators to develop enhanced signaling applications. Here are some examples of applications we are developing for mobile network operators today. One of our customers has asked us to help them detect silent roamers. These are people afraid to turn on data services when they roam. Industry estimates show that of the 75 million subscribers who roam each month, about 70% of them don't use data services when they roam. So we're developing a signaling solution that identifies those subscribers and provides intelligence to the network operator. It allows the operator to send the subscriber an offer to purchase a low-price data pass. Another application is a mobile operator group has asked us to help them enable local breakout services for their group members so they can offer free roaming in sister networks and not have to backhaul the data to the home network. A third application is a hub provider has asked us for assistance in building a sponsored roaming hub where IMSI ranges are borrowed from an operator with a large number of roaming agreements, and those IMSIs are loaned to smaller operators that do not have the roaming reach. These are the kinds of applications that will increase revenues and delight your customers. Note, in some cases these applications require both 3G and 4G signaling. The DNA Group supports both. So here are the key takeaways. The signaling control plane is rich with data about your subscribers, your visitors, and their usage. By deploying an intelligent Diameter router, that is one with IQ, mobile operators can gather real-time information about their subscribers and make real-time decisions that enhance the customer experience. So we recommend that you place intelligent devices in your network to extract data from your network in real time. Plan ahead. Deploy devices that have the programming flexibility today, even if you don't know what the application will be. The IQ feature can be turned on when you need it. It's better to prepare for it now rather than do an expensive retrofit later. Also, it's just not Diameter routers that need IQ. Look at your SIP infrastructure and your data infrastructure to ensure that you have the programmability at those layers as well. Finally, Diametric has a deep talent pool of signaling experts that can help you develop your applications. Please contact us to discuss your signaling and application requirements. Thank you.